Hi everybody. For today we are going to be talking about dilations. Dilation means that you're making the image larger or smaller. So the notation for dilation is a capital D, and then most times they won't tell you the center if you're on a graph because you would assume the center is the origin, just like we did with rotations. And then they would tell you the scale factor, by how many times is it larger or smaller. So if they don't give you the center and they just give you a scale factor, that means the center is the origin, 0, 0. Okay? So that's really the notation for dilation. I'm going to give you an example now. So let's say I want to dilate about point A by a scale factor of 3, line segment BC. So let's really notice how I'm analyzing what it's saying. So here is point A. Here is line segment BC. So now what this means is that B and C have to be 3 times the distance away from A. So this distance and direction, it now has to be multiplied by 3. So if I copy, here's the second if it was a dilation of 2. And then here's the third, it dilated by 3. So this is where my new B prime is, because it is 3 times the distance away, and in the same direction too. Notice how I copied and pasted that line. Look at the distance and direction that C is. It's in this distance and direction. So that needs to be 3 times the amount. So here's 2 times the amount away. And then here's 3 times the distance away. So here is now where C prime will be. So now this line segment should be, if I copy this, it should be 3 times the length. So 1, 2, oops, and 3. See? It's just about perfect. So that's how I dilate by 3. If I were to do 1/3 though, that's a fractional amount. That means I want to be 1/3 of the length or 1/3 of the distance away, which means I want to be closer. I almost tell everybody A is like Superman when he lands in a movie. So when Superman lands, everything just disperses around it. It just, boom, all in different directions, in the direction that the wind is coming. So if Superman lands here, he's pushing B further away. If Superman lands here, he's pushing C further away, whatever distance and direction it is from the center. If it was a smaller number than 3, like I said, maybe if I had 1/3, it would be pulling it closer. It's almost like putting the movie in rewind. When after Superman lands, rewinding it so that everything's back to closer, getting closer to A. So there has to be a center. So what's important is that when the dilation, when the scale factor, the number they give you is larger than 1, it's going to make the image larger, as we just witnessed. Since we had the number 3, it made it larger. If it's between 0 and 1, so if it's a fractional amount, like for example, if I have 1/2 or 1/3 or 2/5, so that's a weird fraction, they probably won't ever give you that, it will make the image smaller. If I have a negative number, it'll cause the image to be reflected. Well, we don't need to use the word reflected. It will cause the image to we could say the word jump to the other side of the center. So going in the opposite direction. So if here I had a -3, so for example, if this scale factor was a -3, it would have to go 3 in the opposite direction of where B is. That's where B prime would be if this was a -3. 3 distances in the opposite, completely opposite. So like in the 180 degrees. So if it said like this. Okay? Same thing here. It would be in the opposite direction. That would be for C. But I'm not going to make this too messy, so just so you get an idea. So the cool part is that if I just have a coordinate like this, and I want to dilate it by 3, notice they didn't give you a center, but the center is the origin, 0, 0. So the distance actually is tripled. So I could just do 3 times 2 and 3 times 4 to get my new coordinate, which is 6, 12. If I want to dilate by 5, it's 10, 20. If I want to dilate by 1/2, half of 2 is 1 and half of 4 is 2. If I want to do a -2, it's -4, -8. So notice you could just multiply when the center is 0, 0. So I'm going to note that when the center is 0, 0, the origin, you can multiply the coordinates. Okay? So keep that in mind. Here's some practice problems if you would like to try them. So I just want to show you in number 16 what it would look like. So we have A, B, and C, which I'm going to graph right now. So I have -1, 2. Here's A. B is 0, 6. So here's B. And then C, I'm just trying to move this here. And then C is 5, 4, 3, 5, 4. So here's point C. Now notice it actually tells me a dilation of 2, but it does not give me the center. So if it doesn't give me the center, I could assume that they're telling me the center is 0, 0. So what I could do here, just so that my work is nice and neat, is I could actually write the coordinates, and then since the center is 0, I could just multiply everything by 2. So if I want to dilate by 2, A prime would be at a -2, 4, B prime would be at a 0, 12, and C prime would be at a 10, 8, because I'm multiplying everything by 2. So here's A prime, and then here's B prime, and then here for 3, 5, 3, 4, I believe right here. Here's my C prime. So notice all these lengths are now 2 times bigger, but also since they are the same shape but a different size, does anyone remember what we call that? When something is the same shape but a different size, they are similar. Okay, so we mentioned that on the first day. So a dilation creates similar figures where they are the same shape but a different size. Okay, so that's really how you do a dilation. I mean, there are a bunch of other extra practice problems, but I think it's pretty straightforward. If you have any questions, please feel free to reach out, and have a wonderful day.